Hello students, welcome back to Electrical Science course. In this lecture, I'll explain how to write down nodal analysis and mesh analysis equation directly by seeing the circuit. So coming back to writing the final nodal analysis equation directly by inspection. The condition which we need to satisfy to write a final nodal analysis equation by inspection is the circuit should contain only resistors and independent current source. First, as soon as a problem given, cross-check whether the circuit contains any voltage sources or any other branch elements other than resistance. So, if the circuit contains only resistors and then only current sources, then we can use this nodal analysis method by inspection. So first you need to identify number of unknown node voltages. If at all you carefully observe the circuit, the circuit consists of three nodes. Out of the three nodes, this node is taken as a reference node. The unknown node voltages are V1 and V2. So the final equation, if at all you go with a normal procedure, that apply a KCL at V1, write down the KCL equation, then rewrite the equation in terms of node voltages, and after that apply the KCL at node 2, write down the current equation and represent the currents in terms of node voltages. After that, simplifying the equations and finally writing in a matrix form, then you are going to obviously you are going to get 2 by 2 matrix. So in this method, I am going to explain how to write down final matrix equation or final equations. The step one is convert all the resistors into conductance. For example, in a problem, the resistance R1 is 2 ohms. Convert the 2 ohms into conductance by taking 1 by 2. And then, for example, the resistance R2 is 4 ohms. Convert the 4 ohms resistance into conductance as 1 by 4. So in this way, convert all the resistance in a given circuit into conductance. Now, as there are two unknown voltages, so we can consider this as AX is equal to B. So X matrix will consist of two unknown voltages, V1 and V2. Now, we need to fill up the 2 by 2 matrix. We need to fill up, this is A and this is X, and which is equal to B. So A matrix is a conductance matrix. Okay. So first we need to fill up one element. That means the element in a matrix which belongs to first row and first column. So the way we need to fill up this first row, first column is add all the conductances which are connected to node 1. If you carefully observe, G2 is connected to node 1 as well as G1 is connected to node 2. So first we will fill up the diagonal elements. The diagonal element of 1 and 1 is adding the conductances which are connected to node 1, that is G1 plus G2. Similarly, we'll try to fill up 2 by 2 element, that is second row, second column. How we need to fill up is in a diagonal element, simply sum up all the conductances connected to the node. Now, if you carefully observe, G2 is connected to V2 and G3 is also connected to V2. Okay, that means for the node 2, it is joining, or the conductance which are connected to node 2 are G2 and G3. So we can fill up the 2 by 2 matrix as G2 plus G3. Now coming to half diagonal elements, first row, second column. Try to identify the conductance which is common between first node and second node. If you carefully observe, the conductance which is common between V1 and V2 is G2. Okay, so first write down G2. The half diagonal elements is a minus of the conductance which is common between first node and second node. And remember, 1 2 element is equal to 2 1, because if you carefully observe, the element which is common between second node and first node is also G2. So 1 2 element is equal to 2 1. This will also become minus G2. So in a nutshell, okay, first identify number of nodes, So based upon that, A matrix size will be determined. If number of unknown nodes are 2, the A matrix is 2 by 2 matrix. Diagonal elements are filled by identifying the conductance which are connected to particular node. Simply sum up those conductances. And off diagonal elements is identify the conductance which is common between first node and second node. Write down that conductance value with a negative sign. X matrix, directly we can fill up what are the unknown node voltages which you want to determine, that is V1 and V2. Now very important, and we need to be careful while writing a B matrix. Ax is equal to B. So B matrix will contain the current source values. Okay. So if at all the current is an incoming current, we will take it as a positive value on the right hand side. If the current is leaving that particular node, it is considered as a negative value. So let us identify what are the currents coming from the current sources at node 1. Okay, so this is I1 which is coming inside the node 1, and there is I2 which is leaving the node 1. So if you apply the current sources which are incoming and outgoing, the resultant is I1 is incoming, I2 is outgoing. So we need to write down final equation, that is I1 minus I2. If there is only one current, we are going to write that particular current source value. Okay. If it is incoming current, positive value, outgoing current, negative value. Now observe the second node. Second node is being connected to only one current source. The current source value is I2 and it is incoming current. So simply we need to fill up as I2. So using this inspection method, we can directly write down final nodal equations. Now let us try to write down the nodal equations matrix for the above circuit. As you can see in a given circuit, the number of node voltages which we need to determine is given as V1, V2, V3, V4, and this is considered as a reference node. If at all you want to go for a normal method, we need to identify the current directions in each and every resistor, apply the KCL at V1, V2, V3, V4, then represent those current in terms of node voltages. After that, simplify those equations and finally put it in a matrix form. As you can see in the given circuit, it consists of only resistors and current sources, that is independent current source. So we can go for an inspection method. So as I said, first step in inspection method is convert all the resistors into conductances. Okay, so 10 ohms is converted as a 0.1 mho conductance. 1 by 5 is 0.2 mho, and 1 by 8 is 0.125 mho. 1 by 8 is 0.125 mho. 1 by 2 is 0.5 mho, and 4 is 0.25 mho. So first step has been completed. Now what we are going to do is that, as the number of unknown voltages are 4, so obviously the A matrix will be 4 by 4 matrix. Obviously A matrix will be 4 by 4 matrix, and X matrix will consist of all unknown node voltages, that is V1, V2, and then V3, and then V4, which is equal to B matrix consists of resultant current coming at a particular node. Okay, so let us first observe, let us fill up one and one element in a matrix, first row, first column element. So as I said, diagonal element should be filled up with sum of all the conductances at a particular node. If you carefully observe the node 1, the conductances which are connected to node 1 is zero point 0.2 and then 0.1. So what will be the value of 1 and 1 is 0.3. Just sum up all the two conductances. And then coming to second diagonal element. Coming to second diagonal element. Second diagonal element is 2, 2 element. Okay. Simply sum up all the conductances which are connected to second node. You can see 5 ohm is connected. 8 8 ohm is connected. So 1 ohm is connected. We have to take their conductance values zero point 0.2, 0.125 and 1. So 1 plus 0.2, 1.2, 1.2 plus 0.125, 1.325. So we need to fill up 2 by 2 element as sum of all the conductances connected to node 2. Now similarly coming to node 3, add all the conductances 0.125 plus 0.125 plus 0.25. Coming to fourth node, sum up all the conductances connected to node 4. 1 more, 0.125 more and zero point 0.5. That is 1.625. In this way, we can fill up all the diagonal elements. Now, how we can fill up the off diagonal elements? We need to be careful. See, between node 1 and node 2, the conductance which is common is 0.2. So, 1, 2 element will be minus 0.2. 1, 2 element should be minus 0.2. 1, 2 element should be equal to 2, 1 element. So, in a matrix, this is 1, 1 and this is 1, 2. So, 1, 2 element will be 2, 1 element. Both will be same. And then is there any conductance which is connected common between 1 and 3? There is no conductance which is directly connected between V1 and V3. So 1, 3 element will become 0. Similarly, there is no conductance which is connected common between 1 and 4. So 1, 4 element will be 0. Okay. So in this fashion, we need to fill up the off diagonal elements. For example, we have to fill up row 2 fourth element. Okay, second row fourth column element. So when you are filling up row 2 second element, the resistance or conductance common between second and fourth is 1 mho. Okay, so we have to take this into consideration. So in this fashion, if you fill up, finally we are going to get a matrix equation. You can observe, you take a third node. If at all you take a third node here, so the element, no element is common between third node and first node. Therefore, 3, 1 element is 0. And then the conductance common between third node and second node is 0.125. So it is minus 0.125. And then this is a diagonal element. 3, 3 element is sum of all the conductances which are connected to 3. That is 0.125 plus 0.125 plus 0.25. And then element which is common between third node and fourth node. So it is 0.125. So minus 0.125. In this fashion, you can fill up the A matrix. B matrix consists of unknown node voltages. And let us concentrate on B matrix or else right side of the matrix. If at all you see that node 1, only 3 amperes of current is coming inside. So we have to fill up, this is incoming current plus 3. If you consider the node 2, there are 2 current sources which are connected to node 2. 1 ampere is outgoing, 2 amperes is outgoing. So 2 plus 1, both are outgoing currents, therefore minus 3 amperes. Now coming to node 3, no current source is directly connected to node 3, therefore 0. Coming to node 4, you can see there is an incoming current coming from 4 amperes current source, as well as these 2 amperes will come over here. Therefore, 2 amperes plus 4 amperes, both are incoming currents at node 4 plus 6. Once you get a final equation, we can simplify this matrix to determine V1, V2, V3, V4. Very similar to nodal analysis, we can also write down the mesh analysis equations directly by inspection. One thing we have to remember is the whenever we want to write a mesh analysis directly by the inspection, the circuit should consist of resistors and only independent voltage source. And it should be a planar circuit. As we have mentioned, mesh analysis can be applied only to a planar circuits. So let us consider a simple circuit. As you can see, the circuit consists of 3 resistors and 2 independent voltage source. We can apply the mesh analysis directly from inspection method. First step is draw the mesh currents. Let the mesh current for the first mesh is I1, second mesh current is I2. So number of mesh currents is equal to 2. So the matrix will be 2 by 2 matrix. So A will be 2 by 2 matrix, B will be 2 by 1 matrix because number of unknown currents is 1. And right hand side matrix B matrix consists of independent voltage source. Remember, if at all when you are writing or when you are going through a mesh, if you are encountering minus to plus, it will be transferred to right hand side, so it will become plus. When you are going through the mesh equation, if you are touching plus to minus, when you transfer it to right hand side, it will become minus. As very similar to writing the matrix for a nodal analysis, here the diagonal elements is equal to sum of all the resistors in a particular loop. Now let us travel a first loop. When you traverse from node 1 to 2, we are encountering R1. When you traverse from node to 3, you are encountering R3. And when you are traversing node 3 to 4, you are encountering 4 to 1 minus V1. Okay. So first, the diagonal element here is sum of all the resistors in a particular mesh. So if you travel in a mesh, we are encountering R1 and R3. So 1 element is R1 plus R3. When you are traveling in a second mesh, you are encountering two resistors R2 and R3. The diagonal elements is sum of all the resistors in a particular mesh. Very similar to nodal analysis by inspection, the off diagonal elements is identify the resistance which is common between the two meshes. You can see R3 is the resistance common between first mesh and second mesh. So 1 2 element will be minus of resistor which is common between first mesh and second mesh. Okay, so my 1 2 element is equal to 2 1 element. This will also become R3. And coming to B matrix, when you travel through the mesh 1, you are touching minus to plus. So it is minus V1. When you transfer the minus V1 to right hand side, it will become plus V1. If you travel through the mesh 2, you are touching plus to minus of V2. So it is plus V2 when you transfer, or when you move this V2 to the right hand side, it is going to become minus V2. In this way, we can write down the final mesh equations. So the size of A matrix depends upon number of mesh currents. If number of meshes are 3, it is a 3 by 3 matrix. If meshes are 4, 4 by matrix. And X matrix depends upon number of mesh currents. And B matrix will consist of independent voltage source. When you are touching plus of a independent voltage source, on right hand side it will become minus, and vice versa. So in a nutshell, so we can write down the complete mesh current equations directly from observation if the circuit consists of only resistors and voltage source. So it consists of R into I, this should be I, is equal to V. Okay, so as I said, the resistance is the diagonal elements is sum of all resistors in a particular mesh, and off diagonal elements is minus of the resistance common between first mesh and second mesh. Okay, so all the diagonal elements is sum of all resistors in that particular mesh or loop. Off diagonal elements are minus of resistor value common between two meshes. Let us try to write down the final equations. If at all you want to write down in a normal method, we need to write down all the mesh equations and then simplify those mesh equations. And finally, we need to bring it to a matrix form. But as you directly from the observation, from the figure, I can say the matrix is 5 by 5 matrix. The A matrix will be 5 by 5 matrix because 5 mesh currents are there. And then the current X matrix will be I1, I2, I3 up to I5. And B matrix consists of all the voltage source. Okay. Let us observe if at all first diagonal element is 1 1. Okay. So simply add all the resistors in a first loop. 5 plus 2 plus 2. So first element in A matrix will be 9. How to fill up the 2 element, that is diagonal element. Add all the resistors in a second mesh. 2 plus 4 6 plus 1 7, 7 plus 1 8, 8 plus 2 10. Okay, coming to third loop, add all the resistors in third loop. That is 2 plus 3 5, 5 plus 4 9. Remember, you should not add any voltage sources. Simply add all the resistors. Coming to fourth loop, 1 ohm, 4 ohm and 3 ohm. So 4 plus 3 plus 1, that is 8. And in a fifth loop, 1 ohm and 3 ohm. So totally 4. So in the same way, we can complete all the diagonal elements. So diagonal elements are the sum of all resistors in a particular mesh. Now let us try to fill up the off diagonal elements. So first I am filling first row, second column. So identify the resistor which is common between first mesh and second mesh. If you carefully observe, the element which is common between first mesh and second mesh is 2. So in a matrix, it will become minus 2. 1, 2 is equal to 2, 1. Then we need to find out, we need to fill up the element 1, 3. That means identify the resistance which is common between first mesh and third mesh. You can see 2 ohms is common between first mesh and third mesh. So it will become minus, okay. So 1, 3 is equal to 3, 1. In the same way, we need to find out the element common between first loop and fourth loop. There is no element which is common between first loop and fourth element. So it will become 0. Okay. So in the same way, there is no element common between first loop and fifth loop. Therefore, it will become 0. So 1, 4 is equal to 4, 1, 1, 5 is equal to 5, 1. In the way we can complete. So let us try to fill up 2, 3 element. Okay, the element which is common between second mesh and third mesh. So if you carefully observe, the element which is common between second mesh and third mesh is 4. So it will become minus 4. So 2, 4 means we have to identify the element which is common between second mesh and fourth mesh. So it is minus 1. In the same way, if at all you want to fill up 2, 5, identify the resistance which is common between second mesh and fifth mesh, that is 1, so minus 1. In this way, we can completely fill up the A matrix. Let us try to find out how we can fill up the B matrix. So if you carefully observe, if you travel through mesh 1, we are touching minus to plus 4 volts. So first element will become 4 volts. Now if you travel through second mesh, first you will touch plus to minus 4 volts. Okay. And then minus to plus 10 volts. So plus 4 minus 10. So minus 6. If the minus 6 is being sent to right hand side, it will become plus 6. Now come to third loop. So first we are touching plus to minus. If you travel in a clockwise direction, we need to travel in a clockwise direction. If it travel in a clockwise direction, first we are encountering plus 12. Then we are encountering minus 2 plus 6. 12 minus 6 is 6. If you send the 6 to right hand side, it will become minus 6. Now coming to fourth loop, there are no voltage sources, 0. Fifth loop, if you travel in a clockwise direction, you are touching plus to minus. Okay, so it is plus 6. If you take the plus 6 to right hand side, it is going to be minus 6. Okay, so first add all the resistors in a first mesh and then identify the resistors common between first mesh and second mesh and first mesh and third mesh and fourth mesh, first mesh and fifth mesh. In this way, we can fill up the complete mesh analysis equation. So let us do a simple problem. Write down the mesh equations and cross check. So how many meshes are there? 1, 2, 3, 4. So simply we will get 4 by 4 matrix. So first diagonal elements is add all the resistors in a first mesh. 2 plus 4 plus 1 plus 4. And then second diagonal element 2 by 2 is 3 plus 2 plus 4. 3 element will be adding all resistors in a third loop. So 3 plus 1. 4 by 4 element will be 2 plus 4 plus 1 plus 2. Sorry, you should not add a voltage source. Be careful, you should not add a voltage source. 2 ohms plus 4 ohms plus 1 ohm. What is half diagonal element? Identify the resistor which is common between first mesh and second mesh. This is the common element. Minus 4. 1, 2 is equal to 2, 1. And then identify the resistor common between first mesh and third mesh, 1 ohm. So minus 1. 1, 3 is equal to 3, 1. Identify the resistor common between first and fourth mesh. There is no resistance common between first and fourth mesh. Therefore 0. 1, 4 is equal to 4, 1. In the same way, 2, 3 element is identify the resistor which is common between second mesh and third mesh. No element is common between second mesh and third mesh. 2, 3 is equal to 3, 2. Identify the resistance common between second mesh and fourth mesh. 2 is the resistance common between. So 2, 4 element will become minus 2. 2, 4 element is equal to 4, 2 element. So identify the resistance common between third mesh and fourth mesh. So there is no resistance common between third mesh and fourth mesh, therefore 0. Now how to find out the total voltage on the right hand side? If you travel in a mesh, I am going to touch minus 2 plus 4. So if you take the minus 2 plus 4, that is minus 4, send it to right hand side plus 4. If at all you take a second loop or second mesh, there are no voltage sources, 0. If you take a third mesh, you are touching plus 2 minus. So it is 2 volts. If you take the 2 volts to the right hand side, minus 2 volts. If you travel in a fourth mesh, you are touching minus 2 plus, minus 2 volts. If you transfer that to right hand side, it is plus 2 volts. So in this way, you can try to write down the mesh equations for the problem given.